All right, so let's do some practice. So I want to name the transformations. So example 1, let's say we have y equals x minus 2 quantity squared minus 1. Okay, so I know this is a quadratic. I know it's quadratic because the x is squared. It's not like your regular parent function. So let's just go back over the parent function. So the parent function is going to be f of x equals x squared. So basically, I'm trying to say how this is different from the parent function. I wonder if I can write in this pen and if it will look. Oh, that is so neat and not necessarily what I needed. Let's just do like a purple. I think that would be good. I don't know how to get this off. Oh, there it is. Oh, look at me learning so many things today. Okay, so what I notice is different in example 1 from the parent function is that I have a minus 2 here and I have a minus 1 here. So I need to go ahead and list those transformations. So according to what I've done earlier, this negative 2 in the parentheses, so if there's a negative 2 in the parentheses, it looks like I'm going to be a horizontal transformation, and since it's negative 2, it looks like I'm going to be going to the right. So that means that I would translate right 2. So I would go 2 steps to the right. And then here, for that minus 1 that's on the end there, it's not in parentheses, so it's going to be vertical. And it would be, I would translate, and that's going to be down 1, because that's a minus 1. So if you go back to our notes here, right, when I have this minus k on the end like this, that means I actually go down. So those would be my transformations for that example. So example 2, what if they don't give me the whole equation? They just give me the notation. So the notation being like 1 over 4 f of x. So they just give me this notation, 1 over 4 f of x. Well, they've already told me what the parent function is. The parent function is right here. So the parent function is f of x equals x squared. Well, they've already told me that. So I know that it's some form of x squared and that it's 1/4 in front of that. So if I were to write that as an equation, if I wanted to write that as an equation, I would write y equals 1/4 x squared. That's what it would be if I wrote out the whole equation. Now, I don't necessarily need to do that to find the transformation. I have a 1/4 in the front of the f of x. So if I go back to my notation, I have an a value in front of the f. When I have that, it's a vertical stretch or compress. 1/4 is going to be between 0 and 1. So that's going to be a compress. So I'm going to say that's a vertical compression by 1/4. So that would be a vertical compression by 1/4, meaning I would take my parent function and I would press it 1/4. All right. What if I have y equals negative x squared? Well, the only way that this is different at all from the parent function is that negative in the front. And if I look back at my notes here, I can see that when there's a negative floating in the front right there in front of the equal sign, and you're going to see that right here when I have a negative floating in front of the equal sign, that means I have a vertical reflection, also known as a reflection over the x-axis. So I'm going to come right down here, and I'm going to write reflect over x-axis. Number 4, y equals negative x minus 3, and all of this is squared. Now, when something like this happens, when you have this value in front of the x, so like when you have if you have parentheses and there's anything in front of the x inside the parentheses. So first you want to see those parentheses. So here are my parentheses, and then inside of them, there's a negative right in front of the x. So whenever that happens, the first thing you want to do is factor. Okay, you don't want to leave that negative chilling with the x. So let me show you what that means. So the first thing I'm going to do is factor it. So y equals negative x plus 3, and all that is squared. So what I did is I factored out -1. Now the reason I did that is because the b value is that number factored out there. So if you go look at the equation here, see how the b value, look at the b, is like right here in front of the parentheses, but still squared. That's what I'm trying to get it to look like. I'm trying to get it into this form here to match with the sets of parentheses. So now that I've done that, I'm going to come down here, and now I'm going to find the transformation. So that negative is in the parentheses, and it's that very first thing. So that's going to be a reflection. I'm going to reflect over the y-axis on that one. And I can see that in parentheses I have a +3. So that is a translation, and I'm going to translate to the left 3. Remember, everything in parentheses is opposite. So in parentheses, a +3 doesn't make you go right. It actually makes you go to the left. Okay? So number 5, we have f of x equals 4x plus 4 quantity squared minus 2. So let's take a minute. Think about what transformations you see here. Some are really obvious, some may not be. Okay, so let's see what we see here. First, this is an equation. I notice that it has f of x instead of y, but that doesn't make it not an equation. This is an equation form. I have a number in front of x inside the parentheses, which means that number needs to be factored out. So I'm going to change that to 4 times x plus 1 squared minus 2. I want to make sure that, should be 2 parentheses, sorry about that. I want to make sure that everything in my parentheses is always completely factored. Now I'm ready to find my transformations. So this 4 in the front, that is going to be a horizontal compression because 4 is greater than 1. So horizontal compression by, and now here's the weird part. You would think it'd be by 4, but you would be wrong. We actually do our horizontal compressions by 1 over b. So this would actually be a horizontal compression by 1 over 4. Then, looking here, I see that I have a +1 in parentheses, so that means I'm going to translate. I'm going to translate left 1. And then there's a -2 on the outside of the parentheses, so I'm going to translate down 2. All right, last example in this particular form, let's look at f of x plus 2. So that's f of x plus 2. Now this is just in the notation. You can take this notation and you can write that as an equation. You don't have to. To find the transformations, you don't have to do this, but it is a fun thing to do. So if I have f of x plus 2, what that actually means is that I have y equals x plus 2 quantity squared. Now, there's nothing in front of the x. Notice that there's nothing right here between the parentheses and the x. That means I don't have to do any factoring. I'm actually ready to go ahead with my transformations. So the transformation here, the only thing I see is that +2, and it's in the parentheses. So that means I'm going to translate left 2 steps, or 2.
It's hilarious because we have you on camera.
I know, right?
Oh my god. Oh my god.